really gone into the lines, and we've done a little bit of repainting, but I'm assuming we'll probably get a little bit more information on that today.
Correct.
So the way I was able to set up the dots was using a nested for loop.
Okay.
And using the paint method to paint round rectangles, which looks a lot like dots, kind of looks similar to what yours was.
Sounds good.
But I'm not sure if that's a good way to implement it, because I don't know how we're going to draw the lines or all that kind of stuff just yet. Does that sound about right?
So yeah, to draw the board, you're basically going to do exactly that. Do a pair of nested for loops, and you can draw tiny rounded rectangles, or you can use draw oval, which you can use to make a little circle, and you can do fill oval to make it filled in. And any of those are good options.
Okay. I just didn't know if I stumbled across something that worked but isn't exactly what we're looking for, or if that's exactly what we're doing.
That sounds perfectly good to me. And remember, for the most part, on PA4, you kind of get to make the design decisions however you like. So if you wanted to implement the dots game with little square rectangles, you could do that. That's certainly, you know, within the scope of your artistic decisions.
Okay. Yeah, I don't know. I mean, I guess I kind of understand the whole coordinate system, and that's kind of how we're going to implement our lines and the drawing and all that stuff. But I know that you also talked 2 days ago about using booleans for, like, seeing whether the box is actually there or if it's just another line.
Right.
So I didn't know if there's another kind of interface those dots have to be on or something like that. But
well, so we're going to talk in some detail about how to figure out, you know, what line has been clicked near and good stuff like that. So we'll pin down a lot of those details over the next couple of hours.
Awesome.
All right, and I think I am just about set up here, so good timing. Let's see. So yeah, as I said, my plan was to go over some logistics about the midterm, and then to talk a little more about drawing using the paint method and using repaint and things like that, and then talk about coordinate math and how to take XY positions of mouse clicks and figure out what to do with them for PA4. But any other questions before?
Do you have a study guide by any chance? I know in the previous courses you've had that.
No, study guide is really just everything we've done up to, but not including the swing stuff and the event-driven stuff. So basically everything on the first 3 programming assignments, all the ODPs, and the material related to those. And your best bet for studying is, you know, go through your notes. Definitely go over the code from the programming assignments, the ODPs. Make sure the code makes sense to you. If you got the thing to work at the last minute and you kind of breathed a sigh of relief, that's good, but make sure you've gone back and you've worked through the code and you actually understand what it does and why it works, or if there was something that didn't work, you understand why that was and how you could rectify that. And just make sure that, you know, the kinds of things you had to do for the programming assignments, that you feel pretty good about doing those.
Okay, perfect. Sounds good. Thank you.
Yeah. All right, well, let me pop up Canvas. And let me just run through this announcement I made the other day. So this was just a reminder of 2 things. One, you know, your midterm is on Thursday. It's scheduled for 1 o'clock. So If you don't have an extended time allowance, the exam is from 1 o'clock to 2 o'clock. It will be on the Canvas page near the bottom under midterm. And you'll want to refresh right before 1 o'clock, and there'll be a download link in here. I'll probably lock it a few minutes before. There'll be a download link. You download a PDF that will have all the questions, and then you write up your answers by hand, upload them as a PDF to Canvas. So the same as we've done in 224 and 222. And so a few details. You have to take it during the scheduled time. It's not an exam that you can take any time on Thursday. It's scheduled from 1 o'clock to 2 o'clock. You have to upload a PDF, and that should contain your answers. If you submit late, it's a severe time penalty, right? 10 points per minute. So make sure you turn it in, you know, like a minute before 2 o'clock. Unless you have extended time. If you have extended time, just take the extended time. If you have a 2x allowance, turn it in before 3. If you have time and a half, turn it in before 2:30. Canvas will tell you it's late. Don't worry about that, right? I've record whether it's late or not myself, based on accommodations. As I told the other section, do not discuss any aspects of this exam with anyone until after 3 p.m. on Thursday. So the exam ends at 2, but we'll hold off an hour, which means I'm not going to go over the exam in class on Thursday. We'll talk about it the following class on Tuesday. All right. The other detail is the honor statement. So there's no honor statement in the exam to sign. You're agreeing to these terms by taking the exam. So what are the rules here, right? Obviously, the work you do has to be your own, entirely your own. You can't receive any assistance from anyone except me. You can't offer assistance to anyone. If someone inadvertently gets assistance from you, if you don't say anything but you let them see, you know, what you're writing, that's considered cheating. All right, so it's got to be, you know, each person doing their own work in the entirety. The only exception is you can ask me for questions and stuff. Exams closed book. You're allowed note pages, 6 double-sided pages or 12 single-sided. You can type them, you can handwrite them, you can, you know, mimeograph them, whatever you're into, that's fine. No other resources though, okay? So no web access, no online documentation, no audiobooks, no sample code, nothing unless it's on your 6 pages of notes. But you can put whatever you want on there, so if you can't remember, you know, how to construct a scanner, you know, put that in your notes, or take a excerpt of the scanner documentation and put that in your notes, or take your code from PA3 and put that in your notes. We're mostly going for low-hanging fruit here, so, you know, strings, scanners, file, hash maps, linked lists. These are the main classes we've been working with. We're not doing anything with swing or jframes or anything like that on the midterm. So it's everything up to but not including this this latest stuff related to PA4. All right, just to be really absolutely clear, hopefully, right? One of the effects of all of this is that under no conditions can you type your code into any kind of editor, Notepad, VI, Visual Studio, any kind of IDE, nothing. You cannot compile code, you cannot execute code during the exam. All right, it's just, you know, you and pencil and paper and however you're viewing the exam questions, and that's pretty much it. So if there's any questions about that, ask. If you're taking the exam and you're like, well, I just want to, you know, type this into Notepad so I can look at it more cleanly, right? And you're not sure if that's allowed, just ask me, right? And I'll either say, you know, sure, or I'll say, no, don't do that. And there's no harm in asking. All right, any questions about logistics? All right.
Do this all by, you have to do this on pencil and paper again?
You have to write it up by hand unless you have a manual typewriter, in which case you could type. All right, and then we'll do a 5-minute break at 2 o'clock, and then we'll have a regular lecture after. A few things I've suggested to other people. You can upload multiple times. So as you finish each page of your exam, you can scan it. If you have a slow scanner, you could let it scan while you're working on the next problem. And then once you've got the page scanned, throw it into a Word document, Google Docs, whatever. Just paste it as a new page in a document that you're building, and then export that and upload it. And I don't mind if you've got 7 exports during the exam, 7 uploads during the exam. I'll go ahead and I'll grade the latest one. But this way, you don't have to allocate time to scan several pages and convert them and upload them at the end. Do it as you go. Right, open a Word document or an open Office document or something. Finish a page, scan it, paste it into your document, and you've got this document being built throughout the exam time. But figure out ahead of time how you're going to do this. Right, you don't want this to become a big chunk of your effort on Thursday. So figure it out ahead of time. Come by office hours. Well, this morning's already gone, but Thursday, if you want, we can try to go through some of this if you need help figuring out different tools or something like that. All right, any other questions on this? All right, well, let's talk more about painting in Swing. Or questions about anything, PA4 or whatever. All right, so let's go back to some of the code we were playing with on Tuesday. So I think we were playing with this this program, Painter, and we had this set up with the usual jframe on the outside. So that's right here. And then a content pane inside. And the content pane is normally a J panel. We changed it to a My panel. And then we created a My panel class that extended a J panel. So when you try to run your program, sometimes you have to make sure that you're in the tab that has your main method. Otherwise, Eclipse doesn't seem to know which one to run. So we had this kind of thing going. And I don't remember how far we got last week. Did we throw a linked list into this?
We did a linked list, and then we removed the last characters, obviously, from the list, or the last spots from the list, so that it would either be like a snake or a very small line if you were slowly moving the mouse.
All right, cool. So we had a queue basically with a linked list.
Yeah.
All right, let me see what I got here. I'll be back in the main window in a second. All I don't know if this is what we had. Oh, okay. I think this was what we had.
Yes. Yeah, it looks familiar.
All right. So we got that kind of thing going. All right. And we've got all this extra stuff that I don't think we need. So I'm just left clicking these and then just hitting the delete button. But you know, you can right click and delete also. But I'm just going to clean this up a little bit here. Couple of things we can do with this. We've got this linked list. It's holding 50 points, right? So pairs of x, y's. And remember, we put this call to the superclasses paint method in the beginning. And if we didn't do that, then a few weird things happened. Like the border of our panel didn't appear. And when we change the size of the window, a bunch of our dots disappear. And the reason for that was that the superclasses paint method does things like clear the component, reset everything to the background color, draw whatever border has been requested, and so on and so forth. And so if we don't do that, the panel's not being erased basically, and so the old rectangles we've drawn are still visible, even though the paint method is not painting, you know, this rectangle down here anymore. And so when we resize our window, right, that rectangle disappears, because when we resize the window, there's something else that's saying, hey, let's repaint this whole shebang. And then you can see, you know, the things that you're actually drawing in the paint method versus the stuff that's just left over. So let's just play with that for a minute. And let me take a button and drop it down in here. I guess I can't move it. Let me put a layout manager in here. Well, now I did. I don't know if I got a button or not. All right, there's a button. So if I run this, all right, I've got my button up there, but sometimes my button disappears. And if I move my mouse over where the button is supposed to be, it suddenly reappears. Right? So if you ever get weird behavior like this popping up in your code, think about your paint method and whether or not you need to, and whether or not you are calling the superclasses repaint or paint. The paint button, the new button here, right, that has to be drawn by something. And the thing that draws it is paint, right? But in our paint method, we don't have any code in here that says, oh yeah, draw a little button and write the words new button in the middle of it, right? We're not doing that. And if we don't call the original paint method, this is the whole paint method. It's just one for loop that does a bunch of filled rectangles. And so if you see sort of, you know, flaky behavior going on, if things are disappearing, if things are not looking quite right, go back and see if you're calling the superclasses paint. And almost always we want to do this. And if taking this out makes your code act the way it wants, the way you want it to, you're probably not coding it quite right. Right? So taking this out is not really a fix. It's a band-aid, right? So if we call the superclasses paint, now we've got, you know, our buttons are there, and if we resize, they get redrawn, they don't just vanish, and so on and so forth. I'm going to get rid of this button. And suppose we wanted to do something like have a clear option. Right, so we could go to this button, we could change the text of it to say clear. And then we can right click and we can say add event handler for action performed. And let's clear all points from the linked list here. So how do we do that? How do we make all our points disappear? All we have to do is take them out of memory. Right? Because when paint gets called, it's going to iterate over each element in the linked list. If there's no elements in the linked list, then nothing will, this loop will not iterate, and there'll be no filled rectangles drawn on the screen. So to clear the screen, we don't need to find some magic clear function. We don't need to draw a big gray rectangle that covers all the points we had drawn, right? All we have to do is clear the points from the linked list. So that's the first point, right? This is a data-driven mentality. This is doing what we want to do to the data, to the stuff in memory, so that when things get drawn, they come out looking the way we want. All right, so the next thing is, how do we clear the points from the linked list? So the linked list is in this super cool panel class. It's this thing called last point list. And we've got some choices here. We could, from our button code, we could say, content pane, or what do we call called in my board? We could say my board dot last point list, and we could clear it from there. But if we were being really good about this, this would probably be private, and this would probably be private, and this would probably be private. Sorry?
Probably just want to make a public method that does all the clear.
Yeah, so let's make a method and make that method public. So we'll make a public void clear list. And if we check the linked list documentation, there's a method called clear. Removes all the elements from this list. So that's pretty easy. All we have to do is say last points list dot clear. Last point list. And then over here in our button code, button's been pressed, what should we do? Well, we should call that method on the super cool panel. Well, the super cool panel is called my board, so we can just say my board dot clear, and I forget what I called it. Clear list. Hey, those pop-ups are handy sometimes. All right, and then we have to do one other thing after this. I forgot to save it. We have to do one other thing after this. Remember, all we're doing here is updating the memory. We're removing all the points from the list, but that's not going to cause those points to magically disappear. They're going to disappear because eventually the paint method will be called, and paint will call super paint, which will clear the screen, and then since there's nothing in the list, nothing will get drawn. But until paint gets called, we're not going to see this glorious effect. So if we run our code right now, we can draw in here, and I hit the clear button, nothing happens. But the next time that the super cool panel gets drawn, right, suddenly all those points disappeared. So the other thing you're going to do more often than not is when you do something to update memory that affects the way that things are painted, you're going to want to call repaint. And so we're going to say myboard.repaint, and repaint says, hey, when it's convenient, call paint in the myboard class, the myboard object, and that's going to execute this code. And so now, as soon as we hit that button, it's going to repaint the display, and our dots disappear. All right. So any.
It's kind of a
Mm-hmm.
Sorry. Oh, I was just gonna say, as a philosophical question, would it be, I guess, more appropriate to put it inside the button click, or would it be appropriate to put it inside the clear method?
The repaint call.
Yeah.
It's a good question. I would tend to put it here, unless I called this method, clear list and repaint. I could do that, and then I could put repaint inside. But there may be multiple things I want to do before I go ahead and repaint. Maybe I want to clear the list, and then I want to, draw something else or whatever. But yeah, it is kind of a philosophical question. Now, the one thing we don't want to do, don't force Swing to call paint. You can hop onto Stack Overflow, and you can Google, and you can figure out how to get a graphics object that will work for painting the super cool panel. And from here, you could force the system to call paint and pass that graphics object. It's a really, really not a good thing to do. The reason being that lots of things want to repaint lots of different pieces of the display. That's got to be synchronized. And if you just kind of come along and say, hey, I want this thing repainted, I'm going to do it right now, you can start getting things like, seeing screen tearing and things like that. The painting's normally synchronized with the vertical sync, so that it happens, in between refresh cycles of the display, and so on and so forth. So call repaint. Repaint will say, hey, call paint for me when you can. And then the next time that it's appropriate to call paint, paint will be called in here. Yeah, question or comment?
You generally want to call super paint every time you have some sort of sub-object that's going to be painting, so that you paint from the bottom of the inheritance tree upward, right?
I think it actually forces super to be the first call in the paint method, I believe. If it's not, we might actually get some complaints. But yeah, generally you're going to want to... yeah, maybe that works. Okay, I'm thinking of something else.
Repaint is just going to call paint for you, just it's not going to be like immediate. I mean, it will probably look that way to us, right? But
Exactly, yeah. Repaint basically queues up a request to have paint called.
okay. You don't have to pass anything to that. It's just basically saying repaint it.
Yeah, exactly. So there's no arguments to repaint. And anytime anything happens, when the window gets resized, when it becomes visible or gets partially covered or deminimized or anything, usually repaint gets called, and then at some point, paint will fire as a result of that.
It's kind of interesting. I don't think I've ever used a method that has an inherent call to another method.
Mm-hmm. Yeah, and it's weird because it's not immediate. So it's not like inside repaint there's a call to paint. It's a very roundabout way of calling paint.
Yeah.
But it keeps everything playing nicely together, so.
So, when you say it's waiting for the next free moment to repaint, does it mean it's a synchronous blocking call, or it's like asynchronously waiting for the next time when it should be repaint?
So repaint will return almost immediately. It'll load a request somewhere, probably throw something onto a queue somewhere. And then repaint comes back right away, and in this case we'll just exit from this method, but we could do other stuff and so on. And then at some point when the system is ready to repaint, it will go through that data structure or queue maybe and see everything that needs to be repainted. So kind of along those lines is this other idea of keeping your event handling very short, right? I would not want to do something in here like read from a file or wait for user input or something like that. This is interrupt code, right? This is an interrupt handler. And if I don't come out of here really quickly, weird stuff will happen. Displays will freeze and things might crash if they're set to timeout and so on and so forth. If we want to do something like, wait for user input or wait for something to come in from the network or something like that, we have to do that somewhere else. And the most we could do inside here, if we're doing this in response to a mouse click, is set a flag somewhere or maybe start a new thread, a new process to wait for that input or something like that. But if we start looping inside here, like if we do something like this is the worst kind of loop, so it's a little bit of a weird example.
I noticed while loops in event code is not very awesome.
Yeah. So I mean, my thing is broken now. My clear button has been pressed. It's darkened to indicate that it's been pressed down. But it hasn't even come back from the click, even though I stopped pressing it. And if I try to resize my window, I get this kind of weirdness, and it's just all kinds of messed up right now. And so if I had something that took 5 seconds, right, during those 5 seconds, this is what the user would be seeing. They're going to be like, hey, your code's kind of weird,
Out of curiosity, because I know I've done a similar thing in Unity, and as I looked at my task manager, it basically was just building up memory. I mean, it got like almost up to a gig before I crashed it and restarted.
Interesting.
Is that what's happening here, or not so much?
No, here I'm really just kind of stuck inside this action event, this action performed method, and this was called by something that's responding to events, and so that's not a multitasking process, right? An event occurs, it calls everything that needs to be called to handle it, and then it goes on and it waits for the next event. Well, if it's inside this call right here, it can't go on and handle other events like resizing the window or unclicking the button and so on and so forth. But if you want to run out of memory, this is probably one way to do it. Because if I call the repaint method from inside paint, it's well, I don't know if this is going to run out of memory or not. I think it's
kind of a recursive call to itself, isn't it?
it's not actually calling paint, but it's going to queue up a call to paint, and so I think at the very least it's going to slow things down. But yeah, so that's getting a little pokey. But that's not too bad.
So if you wanted a say a while true, whatever, loop after an event, would that still, so let's say if you had a method that you were calling from the event that had a while loop, would that fire and forget and move on, or would that kind of accomplish the same as, while true?
Yeah, so if inside here I call the method, until that method returns, I'm still, kind of inside my action performed, and the thing that's handling events is basically stuck until I return from here.
Gotcha. So no matter what, inside anything that's called inside of here, you kind of don't want any sort of while loop.
Well, you don't want anything that's going to take a long time. So you could do a while loop if you wanted to do 2 or 3 things or 10 things, right? You could read from a file if you believe that it's going to take a very short amount of time. But the real adage here is keep your event processing as short as possible. And so you definitely don't want to be waiting for user input or doing some calculation that's going to take a second or 2 or something like that, because the whole system will appear to freeze.
Yeah, I mean, there's ways to handle file opening after the event's been fired, stuff like that.
Yeah, and typically we're going to talk about threading in a few weeks. Typically, you could create a new thread that would handle that process. PA5, we're going to be networking our dots game. And so, when you make a move, you're going to send information to the other player about your move, and then you're going to wait for information to come back from their instance of the game to say, hey, they made a move. But we're not going to do that inside the event handler, right? We'll have a separate thread, and we'll update some flags saying, hey, it's the other player's move, and then this other thread will do something accordingly to say, hey, I'm waiting for a move to come in from the network.
Okay.
Does Java have like a task API?
It has a number of classes related to creating threads and managing threads. So I'm guessing maybe that's what you're thinking of by task.
Yeah.
Yeah.
C# got this whole task API that's pretty interesting.
Mm-hmm.
I think it was meant for IO bound tasks, but you can use it for really anything. So anything that might be too expensive for an event.
Oh, okay.
You just set it loose on a task.
Yeah. So we've got some of that going on in Swing already, because in our main method we create this thing called a runnable, and a runnable is one way to create a thread. The other way is to extend the thread class. But this basically creates a new thread that's going to execute, in parallel with everything else. And so, but yeah, we'll spend about a week talking just about threaded programming, and we'll have to use that for PA5. And threads are fun. Making more than one thing happen at once is a nice capability, and it's also a really tricky thing to get right. You can get into lots of surprising issues, a whole new world of bugs awaiting for you, with things like deadlock and live lock and resource starvation and so on and so forth. So we'll have fun playing with all that. Race conditions, yeah, totally.
It's kind of expensive to do all that thread manipulation by hand too, because it's better to like the task API I was telling you about in C#. What it will do is it can smush together lots of threads into certain threads to efficiently use the thread pool.
Mm-hmm.
And
That's cool.
I'm guessing that's what Runnable does to an extent.
Yeah, I don't know a lot about how it works under the hood, except I know if you have 8 cores, you can make 8 threads, and they'll get 100% of the CPU each. It's pretty streamlined. Well, you can get 7 cores, 7 threads running, and when you get to the 8th, it's sharing with everything else on the system. But it's a pretty painless way to do some multi-processing and get some speed up for the right kind of problem, and that's pretty fun. So I had a 28 core system I was playing with a few summers ago, and that was sweet because it was almost effortless to rework my code to take advantage of those. Yeah, go ahead.
28 cores, huh? That's
Yeah.
great. I was going to ask, as far as like players inputting their name, obviously that's going to be an event handler for the text field. But the only thing I'm looking at that looks like it might be what we're using is the input method and then text changed. And then I'm assuming we're gonna make their name a variable string name, right? And use it in that way. But how exactly do we do something like that?
Well, you've got some options. So you know, we can throw down a label. That's easy. And we can throw down a text field next to it. And you know, we can do the goofy thing where it says enter name here, and let's call this something instead of calling it button enter name here. I'm just going to call it name. Probably a terrible choice. All right, so yeah, one thing you can do is you can add an event to this, and some of the events you could hand would be, you know, if a key is pressed or a key is typed, so that every time that the person hits a key here, you run some code, and that may be useful, but not necessarily something we need to worry about, because the person might type something and then backspace to delete some characters and then change it to something else and so on, and we don't necessarily need to respond to all of those events. And you could respond to, you know, key typed and just do something when they hit the enter key, but not everybody's going to hit the enter key. But in fact, you know, you probably don't have to do anything, because you may not care what name they type here until they hit the start button to begin the game. And when the start button is pressed, what can you do? Well, you can go into this text field and you could say get text. And at that point, you could read what this name is, and then you could use that to display something like, you know, Nick's score and someone else's score and so on. And you could also, you know, at that point save it into a string variable, or you could simply say, hey, anytime I want to know what this person's name is, I'm just going to use name.getText and just read it out of here. And maybe when the game begins, what you can do is you can go ahead and you can change a property of this field, which is enabled. And if you make it not enabled, then the person won't be able to change their name. Right? So once the game starts, the name is locked in, and now you can just say name.getText to see their name. When the game is over, you can set enabled back to true, and then if they want to type something different in, they can do that. So you've got a lot of options, right? And they sit on different points in this multi-dimensional space of being data-driven, being object-oriented, and so on.
So is that basically just calling player 2 or whatever you call that box, and then dot enabled equals false?
Mm-hmm.
Is that, okay.
Well, let me be careful about that, because some of this stuff is deprecated. So let's look at jtext field. I think it's probably set enabled as a method, and you say true or false.
So I'm assuming the labels, and I'll go through it and check, but I'm assuming there's a get and a set for each component, so you can change the score from whatever player 1 to the actual name with the set.
Yeah.
Okay. Oh, set enable. Okay.
Yeah. So there's a set enable that takes a true or false. And most of these classes don't have you go in and manipulate properties directly. They usually have you do it through a method. So set enabled can be true or false, and then get text is another method for reading the text.
These methods, you'd use your object dot and then whatever, right? You don't have to go through all of the container and this and that.
Right. No. So in this case, we call the jtext field name. So it's just name dot get text,
Okay.
and
Because all
that'll
those
return a
methods are
string.
inherited, right?
Say again?
All the methods are inherited as that
Right,
being
right.
an inherited class. Okay.
Yep. So yeah, it's actually part of the JText field class.
Okay, perfect. Thank you.
Yeah, you're welcome. Other questions on PA4? Other than coordinate mapping, which is what we're going to do next. I'm going to take a break right before that. All right. Let's go ahead and do a break right now. It's kind of early, but the coordinate mapping is kind of a big, long, wordy exercise. So let's go ahead and take a 5 or 6 minute break, and we'll come back then, and we'll talk about how to relate XY coordinates from mouse events to what's actually going on, to what kind of line is being requested, and so on. And while we're breaking, if you hop onto the Canvas page, I posted an entry on here yesterday under resources called coordinate mapping. That's what we're going to be talking about. So that's a one-page PDF. So if you want to download that to play along, we can do that. But I'll show you my copy of that here. All right, so I'll be back in about 5 minutes. All right. Let's talk about coordinate mapping and dealing with mouse clicks and such. So you know the basic setup for PA4, right? You're going to draw a grid of dots, which you do inside your paint method. You're going to, wait for the person to hit the start button, and at that point, you can find what their names are from the text fields, or, tell them they have to fill in their names, and so on. And so the gameplay is mostly a matter of just hanging out and waiting for a mouse event. And that mouse event, will generate an XY pair, which is passed to, a mouse action listener. And so you end up inside a piece of code, and you're given the X and Y coordinates of where the person clicked. And from that point, you need to figure out, what do we do with that? Does this indicate that the person is claiming a line? Is that line a legal line to claim? And if so, then you go ahead and you set your booleans in the box object, and so on and so forth. So I want to just look for a little while at this question of how do we relate XY coordinates to these boxes. So let me draw a little portion of our game field here. And by convention, these boxes are going to be 50 by 50. And if we're doing this, inside our own panel, so inside the big J panel of the whole frame, we've got this smaller J panel, then this upper left corner is 0, 0. If we don't put a border on it, right, we can put our first dot right there. And this panel can be 400 by 400. And so the last dot will be right here. And so if we think about the coordinates for these dots, right, this is X going across. So this is 0, 50, 100, 150, 200, and so on. And Y goes down, and these are 0, 50, 100, 150, and so on. And so the person clicks somewhere. Let's say the person clicks right here. So we get the XY coordinates of this point from our mouse event. So this is maybe, 90 and 130. All right, so a few things to keep straight which will help us. When we see pairs of coordinates, it's almost always X comma Y. And in this case, X runs horizontally, Y runs vertically, but because it's graphics and computer science, Y runs from the top to the bottom instead of the usual Cartesian coordinates where Y goes from 0 and increases towards the top. So XY is almost always done in this order. So 90, 130, this is X is 90, Y is 130. And if we look at this picture, we can see that, this is sitting inside this box right here. So our first question is, how do we figure out which box the person clicked in? So this download that's available under resources on Canvas looks like this. And this has got a number of pieces of information on it. And I wrote this up a few years ago. So here's a reminder for how XY works. I put a little notation over here for row and column, and this is really useful to keep in mind. When we see things represented with square brackets, almost always the first thing is the row and the second thing is the column. And so if we say, cell 3, comma 2, we're talking about moving down to row 0, 1, 2, row 3, and then going to column 0, 1, 2. And that may just seem like a convention and who cares, but for me, that was the thing that made it possible to work with all of this graphics business, was getting a clear notion in my mind of row and then column. Because without that, you're constantly like second guessing, is like 1, 3 over here, or is it over here? right? So that's worth noting, and I've got that down here. Row goes down, column goes across. All right, so here's a little cheat down here. If you have coordinates x, y, and you want to know what cell it is, it's in cell R, comma C, where R is y divided by the cell height, and C is x divided by the cell width. So if you take your x coordinate and divide it by 50, you've got the column number. And if you take y and divide it by 50, in our case, you've got the row number. And these are integer divisions, and since everything we're doing is integers, you automatically get the result rounded to truncated to an integer. So this tells us row is y over cell height. So our row would be y over 50. Our y is 130, so that's 130 over 50, and that's going to end up being 2. It's 2.6, but as an integer it'll just be 2. And then our column will be x over 50. X is 90, so 90 over 50, well that's 1.8, so as an integer that'll be just 1.
Is that an implicit conversion?
Yeah, so if y is an integer and cell height is an integer, it will do an integer divide.
Okay,
If you
so
divide,
need to explicitly say that it's an
no, you could cast it, but it won't do anything.
Okay.
It
Yeah.
doesn't need to do any promotion or demotion under the hood.
No. But if you divide it by like 50 with a period at the end of the 50, then you're doing a floating point divide, and the result will be a float or a double, and then you'll have to cast it, or it'll say possible precision lost in assignment. So, but if you just do 50, you should be fine. And my suggestion that I made in the assignment was don't have magic numbers. Don't write a bunch of code where you take x divided by 50, y divided by 50. Make an integer called cell height. Make an integer called cell width, and set those equal to 50 when you declare them. And then, this is just, R equal, or row equals y over cell height, column equals x over cell width. And since they're integers, it'll just work.
I got a quick question. I think I know how we're gonna look at the lines now, but I just wanted to ask, are we gonna then basically make a list where we're gonna check that list and see if that line has been painted in those coordinates to say whether or not that's a legal move? Is that kind of how we're looking at doing that?
So, so you could do it like that. Probably the easiest way is, we're gonna have a box class, and just make yourself a set of booleans: top, bottom, left, right, and set these to be true if that line has been claimed on that box. And so in the constructor, set these all to false. And then our board is an array of boxes. So box board, bracket, bracket, equals new box, 8 by 8. And now if I want to know something about, box 3, 2, I just say board, bracket 3, bracket 2, and that's going to be a box. And so I could say, if board 3, 2 top is false, because they clicked right here, then I can go ahead and set it true, and this person, can claim that line.
Oh, so it's gonna be like, okay, if someone clicks it, set that to 2 or true, and then repaint.
Mm-hmm. Yep. Exactly.
Okay.
So this is a little counterintuitive maybe, because the whole thing's kind of driven by the boxes, and even though we're playing the game on a board, all the good stuff happens sort of inside the box class, and the board is just a collection of boxes. At least that's one way to do it. Alright, so these two lines here, you can use that to take an XY pair and figure out a row and a column. And so in this case, we've decided this is row 2, column 1, which I would write like that. Right? And so sure enough, row 0, 1, row 2, column 0, 1, there's our box. All right, so that answers the question, which box? The next question is, where are the corners of the box? I'd like to know the coordinates of these 4 corners. Because, my goal is to figure out, based on this click, what line am I trying to claim? Well, if I know the coordinates of these 4 corners, that's going to make it easier. And so there's another section on this cheat sheet called Coordinates of a Single Cell. And it's basically set up as follows. If you're looking at cell row, comma, column, here are the equations for the XY coordinates of the upper left. It's just column times width and row times height. And then the upper right, the X coordinate increases by the cell width. The lower left, the Y coordinate increases by the cell height. And the lower right, both the X and Y increase by the width and height respectively. So we've got a single box now. Let me do it like this. We've got a single box. We've got row and column equal to 1. The person clicked somewhere in here, which was 90, 130. So let's find the coordinates for the 4 corners. So the XY coordinate up here is the column times 50 and the row times 50. So row column. Column is equal to 1. So column times 50, that will give us the X coordinate. So the X coordinate is 50 times 1, that's 50. And the Y coordinate is the row times 50, while it's row 2, so that's 50, comma 100. And once you've found this upper left coordinate, you can add 50 to X to find this coordinate. So this will be 100, 100. And you can add 50 to Y to find the lower left Y coordinate. So this will be 50, comma 150. And you can add 50 to both to find the lower right. So this will be 100, 150. So now we've...
At that point, you would just set left, right, up, and down to be from this to this, basically, right?
Mm-hmm. Yeah. So find the straight line distance to each edge. So let's look at a straight line from the point that was clicked to the top. And the shortest distance is going to be, keep the X coordinate the same and just use the Y coordinate of 100. So this top line, everywhere along here, Y is equal to 100. We can use this 100 or we can use that 100. But everywhere along this top line, Y is equal to 100. Everywhere along this bottom line, Y is equal to 150. Everywhere on the left, X is equal to 50. We could use either X coordinate. And everywhere on the right, X is equal to 100. Alright, so what's the straight line distance from this point to the top edge? It's going to be the Y value at the top minus the Y value of the Y value of the point minus the Y value at the top. So this is a distance of 30. Distance to the bottom is going to be the Y value at the bottom minus the Y value of the point. That's 20. And so you just do all 4 of these calculations. So distance to the left, we're going to look at X values this time. It's going to be the X value of the mouse click minus the X value at the left, which is 40. and then the distance to the right. That's going to be the x value at the right minus the x value of the click, which is going to be 10. And these are very straightforward calculations. And you can make them a lot more confusing, but I recommend not to do that, right? Don't be afraid to make lots of variables, right? We're starting with just x, y, just two variables, right? I would say go ahead and make another pair of variables, row and column. And then go ahead and make another pair of variables, upper left x, upper left y, and set those equal to, you know, column times cell width and row times cell height. And then make an upper right x and an upper right y and set them equal to that, and a lower left x, lower left y, and so on. Make yourself lots of variables. And now, you know, maybe make yourself another variable for y at top, y at bottom, x at left, x at right. Do you need all these variables? Maybe, maybe not, but they're there if you need them, right?
Would you recommend a separate method to do these calculations and just return something useful to...
That's a nice way to do it, because you'd like to let yourself be as wordy with all of this as is appropriate for you, but it's nice to kind of hide that, you know, inside another method maybe. And so if you can think of a way to pass back the information you need, like all of this is trying to figure out which edge we clicked closest to, and you could pass back, I don't know, an index or something. That would be a nice way to sort of encapsulate all that code. So if you've got all these temporary variables, right, this calculation is just, you know, distance to top equals, and I could just say y at top, or y minus y at top. And distance to bottom equals y at bottom minus y. Or mouse y if you want to be, you know, not a single letter. And distance to left is equal to x minus x at left. And distance to right equals x at right minus x. And now I've got 4 variables with values of 40 and 20 and 30 and 10. Now you just want to find the smallest. And how do you do that? You can do that with an if statement. If distance to top is less than distance to left, and distance to top is less than distance to right, and distance to top is less than distance to bottom, then whatever you want to do to say, hey, the person clicked at the top. And in this case, distance to right is 10. That's going to be smaller than 20, 30, and 40. Since that's the smallest of all 4 numbers, that tells me, hey, the person tried to click on this right line. So now I can check this box's right flag. So, you know, go in and look at the Boolean for right. And if it's not set, if it's false, it means nobody has clicked that line yet. I'm going to go ahead and mark that line clicked.
Here's a weird question, but kind of an edge
Yeah.
case, I think. What if the mouse, or what if like the distance from right and bottom are the same? Like someone clicks in one of the corners.
Mm-hmm.
Do you just make an assumption and hope for the best kind of thing? Or?
So you can choose what you want to do in that case. And sometimes the way you write your code will make that decision for you, but do something deliberate. For example, if I say, you know, if this is less than that, and this is less than that, and this is less than that, do the top. Else, if this is less than that, this is less than that, this is less than that, do the right, right? If I do my code exactly like that, it will not see any edges clicked. Because if this is equal to this, right, it's not going to be smaller. And so none of those if conditions would fire in that case. If I did less than or equal to, then whichever one I happen to check first would be the one that would get credit for the click.
And that's just basically accounting for someone being difficult and trying to throw off the program.
Yeah, yeah. which I mean you always want to do with a new video game, right? Try to like drive off the road and see what's there. But you can also be more deliberate, right? So you could say something like, you know, if distance to top plus tolerance is less than distance to right, and so on, right? And you could specify some tolerance of, say, maybe 5. And now this thing is going to have to be at least 5 less than any other distance for it to count. And so now if someone comes along and they click, you know, equal distant from the top and the right, it's not going to see it as a click. So you can choose what you want to do. And as usual, you know, my suggestion is get something working first, but keep in mind, you know, you can go back and you can embellish this as you move forward. It's nice to get something working quickly, even if it's got some quirks, because it's more fun to play with, you know, graphic code, visual code, where you can point and click and things like that. It's more fun to debug sometimes than just kind of, you know, here's a list of numbers and a seg fault, so where's the problem? But yeah, so you can dial this in a lot of different ways. You can also do things like I've seen students who will also respond to mouse motion. So, you know, this XY would typically be a mouse click. So when you put the cursor here and click, that's when all this code runs. But you could also put a handler for mouse motion that does this constantly. And anytime you get close to a line, maybe it like highlights it, you know, or it changes the color of it or something, so that you can see what that line is that you're close to, and you could sort of see which boxes get completed and things like that. So you can kind of go to town with a lot of different ideas here. Alright, so we find the straight line distance to each edge. We choose which one is closest, possibly with some tolerance. Possibly we just, you know, trust that the user will stay deliberately closer to one edge than another. And once we've decided, oh, they're clicking on this line, we check the Boolean in the box class. And if it's true, if that line has already been selected, we're not going to give them credit for the click. We're not going to change to the other player's turn or anything like that. We might throw up a message, right, or an annoying beep or something, you know, to let the person know they just did something that's not kosher. But we're basically going to ignore it, right? I would say you definitely don't want to do something like throw up a modal dialog box that says, you know, this move is illegal, the line has already been clicked by someone else, okay, and make them click an okay button or something like that. You don't want to interrupt the flow of the game. And sometimes, you know, you want to claim this line and you might accidentally click close to that one. Don't penalize the user, but don't give them credit for it either, because otherwise you can cheat pretty easily. So one thing you can do is you can use the title bar in jframes however you like. So like here's you know, our thing, and we can clear the display and so on and so forth. Well, there's a set title method associated with jframe, and I could use that to do something like this. So if I go into my button handling code, I'm going to clear all the points. I could say something like, what's the name of my main frame here? I'm in my main frame. So I could say, I could just say set title to all points cleared. And now when I run this, I can go around, I can do this. When I hit the clear button, I get kind of an unobtrusive message up here saying all points cleared. But, you know, that message is staying up there until I change it. So what else could I do? Well, I could go into my mouse motion listener, and when I draw a rectangle, I could do something like this. I could go ahead and clear the title out. And now I can draw my rectangles. When I clear, it'll say all points cleared, and when I start drawing again, that message goes away. And so this isn't a bad way to sort of do an unobtrusive informational message, you know, just kind of let the user know something. But, you know, you could also make a text field here that would be a little more obvious, and you could put text in there to say, you know, illegal move or whatever. So up to you, right? Stylistic choices, but you have lots of options. All right, so you found an XY mouse event, and you translated it into a row and a column, and you figured out the corners, coordinates, and you found which edge you were closest to, and you've checked the booleans to see whether or not the box has been that line has been selected already. If that boolean is false, you're going to mark that line as being clicked now. Really important step, that edge is usually an edge of an adjacent box also. So also update the boolean in the appropriate adjacent box. And this is really important. You'll get subtle misbehavior in your code that will get increasingly misbehaving if you don't do that. So we've got some boxes here, and where are we? We're in 2,1, and the person just clicked this line, and so you set, you know, board bracket 2,1 dot right equal to true. Well, you also need to at some point say board bracket 2,2 dot left is equal to true. So this sets this right edge of this box, but we also need to make sure that in this box we've set the left edge to be true. Because at some point someone may complete this box, and if we don't set this edge to be true, it's not going to see that box as completed. So how does this work? In general, if you complete a right edge, then you want to do bracket row, bracket column plus 1 dot left. If you do a left edge, then you want to do row, column minus 1 dot right, and so on.
So for the edges on that, should we check to make sure they're not null first? Like the row column 1?
So,
or column minus 1, I should say.
So before you do this, you want to make sure column is bigger than 0. Because if column is 0, what's happened? Well, you just click the left edge in this leftmost column. In that case, there is no adjacent cell to the left. And if we try to do row and column minus 1, this would be a negative subscript. We'll get an exception. And in this case, on this right, we'd have to say if C is less than 6, if C is less than 7. Because if C is equal to 7, C plus 1 will be 8, and that's too big. And then same for the top and the bottom. So there's lots of little details here, right? These are all things that can trip you up, but write your code carefully. Don't try to do it in a hurry. Don't try to be super slick, right? So keep things simple, at least at first. All of this stuff that we did here, you could do that in like one line, right? I don't need to save the XY coordinates of this corner. I don't need to have a variable called Y at bottom, right? I can do all of that with just a really long equation, right, with lots of parts and pieces to it. But I would recommend not doing that. I would do this in the most straightforward way possible. And so same thing over here, right? Bunch of if statements, right? If C is less than 7, then go ahead and set, you know, board bracket R bracket C plus 1 dot left to be true. And if you're doing this faithfully, right, if I've just checked this edge in this box over here, right, I just checked this edge, I know that this edge must be false in this box right now. Because if someone had clicked over here and turned this on in this box, it should also be true inside this box. So as long as you're doing this, you know, everywhere you're supposed to, I'm guaranteed that, you know, this thing is false to begin with. So do that left, right, top, and bottom, unless, you know, you're at the left edge, the right edge, the top edge, or the bottom edge. And that gives you all of the updates that you need. All right, and then what do? Call repaint. And depending on what your paint method does, that may be all you need to do after a mouse click. Update 1 or 2 booleans, and then call repaint. So what should repaint do? Or what should paint do? Well, go ahead.
Sorry, I can't speak.
That's okay.
It should be able to look through your whole two-dimensional array there and find all the spots where the booleans are true, and then from there you can use the corners to draw lines from point to point.
Exactly. So do a nested for loop, 2 nested for loops, right? For column equals 0 to 7, for row equals 0 to 7. Well, now for a given row and column, you can find board bracket row bracket column. That gives you a box, right? We know the row and the column, so we can find the XY coordinates for each corner of the box. So go through your 4 booleans. If box.top, right, if that's true, then we want to draw a line. Where do we draw it? From XY to X plus cell width, comma Y. And there's a draw line method in the graphics class. It's just g.drawLine, x comma y comma x plus cell width comma y. If the right boolean is set, then we call draw line x plus cell width comma y comma x plus cell width comma y plus cell height. And we do that for each box. And it's okay that, you know, after I draw this line for cell 3-2, I'm also going to draw this line when I'm processing cell 3-3. That's okay. It's drawing a line that's already been drawn. That does no harm. So that will kind of magically, you know, draw the field of lines. And, you know, if you draw all 4 lines, you'll see a box. And there's nothing in your code which says, you know, if all 4 of these are true, draw a box. You're just drawing the 4 edges. And if they happen to all be drawn, bingo, you've got a box. Alright, and then there's box ownership. So if somebody makes a click that completes a box, they get to put their initial in that box. So we need to do one more thing in here after we decide which edge they're clicking on. And we decide that that boolean's not already set. We're going to mark it as true. At that point, we need to check all 4 booleans in this box and see if they're true. And if they are, then this box was just completed, and we need to record this person's initial inside this box. So in your box class, in addition to having booleans for top, bottom, left, and right, you can have a character for the owner and initialize it to empty or something. But if the person completed a box, go ahead and set that character to their initial. And then same thing when you come over and you check, say, the column to the right to see if that box has been completed. If that turns out to have been completed now, then you also need to set the ownership in that box to the current player's initial. And so you could bundle all of that into a method, right? That simply comes back with a boolean telling you, did this move end up claiming a box? And that's really the only thing you need to know after that. Inside that method, you can do all of this checking. You can do the updating of the booleans. You can do the update of the character for the owner. And just return a true or false to say, hey, did this move end up claiming a box? And then if that comes back false, you can go ahead and switch your flag to say, okay, now it's the other player's turn. And if it comes back true, just, return, wait for another mouse click, it'll be the same player's turn. So as you develop this and you start seeing the different parts and pieces of it, you'll probably be sliding them around. You might take all of this stuff and move it down into another method, or you might take something you're doing in here and pull it up to a higher level in your call chain. Or you might take all of these things and say, I'm going to do all this in the paint method and not worry about it here. It's up to you. So one way to figure out the current score, well, the only way to figure out the current score if you're not keeping track of it is to iterate through all of the boxes and just count up, how many are owned by player 1, how many are owned by player 2. And in your paint method, you're going to iterate over all the boxes to draw the lines. And so you could theoretically recalculate the score every time that paint is called. And I know I said to keep things as short as possible, but that's not a lot of extra work. So every time that you go in your paint method and you do these nested loops across row and column, you draw your lines, but also, for each box, check that ownership. And keep a tally in there, player 1 score, player 2 score. And then at the end of painting all your boxes, you can go ahead and update the text field next to, player 1 score, player 2 score. Or you could do that calculation somewhere else and store the scores in a variable somewhere. Or you could do that calculation somewhere else, and in that somewhere else, do a set text to update the scores on the display, right? So lots of choices. It's fun if you make progress on this early enough to be able to go back and approach it different ways. And if you're working in a group, it's fun to, kind of develop this independently, have each person in the group develop it independently, and then start comparing ideas. And someone might say, oh, well, I did such and such, in this method instead of that. And it might be like, oh, that sounds really cool. And you can go off and try to do that, and so on and so forth. All right, so mouse click, check booleans, draw lines, update ownership of the box, figure out if you should change whose turn it is, call repaint, which redisplays the board. As you're going through, check the ownership, and if the box is owned by someone, you can put that player's initial. So another method in the graphics class that's useful is draw string. So draw string will take a string and an XY coordinate. And so if you take the first initial of the player, and remember we have this method called character at. So use character @ to find the first initial and then pass that to drawString. And so you can do this in pieces, or, you know, potentially, if you like sort of making big long statements with nested objects doing their thing, you could do something like this. So let's suppose you have a text field that stores each player's name. So you could do player1 dot get text. That returns a string showing you the name of player 1, you know, that was entered in their text field. And you can say character @ 0. And that gives you the first initial. And you could, you know, add an empty string to that to turn that into a string. And then you could say, you know, g dot drawString. And this would be the string that you pass. And then the x and y coordinates, well, if you want to put an initial in here, what do? You find the upper left x and y coordinate. So maybe this is upper left x and upper left y. Well, the middle of this would be, you know, halfway across and halfway down. And if your cell is 50 by 50, you could do upper left x plus 25 and upper left y plus 25. That'll start an initial right here at the center, so it may actually come out a little bit, you know, to one side, but you can play around with that. But something like that will get you a initial in the box at least. But you don't have to do this all in one big long call to GString, right? You can get the player's name, and then you can get the character that's the first initial, and then you can turn it into a string, and then you can call drawString. Or you can use the substring method on this and just say give me the first character as a substring, and that'll be a string. And you don't have to do character @ and change it to a string and so on. So explore the methods in these classes. Get to know, you know, the string class really well, because it's a really useful class. It's one you'll use a lot. Get to know the character class a little bit at least. And there's multiple ways to do all of this. And you'll go ahead.
What's the syntax for creating an array of a class?
Yeah, let me do that more carefully.
No real difference.
So let's see. So arrays of objects. So let's suppose it's a box object, and let's suppose our array is going to be called board. So we're going to say box, and then the name of the object. And for a two-dimensional array, 2 open and close brackets. And that's really the declaration. And then the construction we can do in the same line, but I'll put it separately so I can put a separate comment. I can say board equals new box, bracket 8, bracket 8. And this will construct the array. But we're still not done. So I got some pseudocode in here for r equals 0 to 7, for c equals 0 to 7. We still need to do this. Board, bracket r, bracket c, equals new box. And this actually constructs the box. So arrays of objects, remember we have to do this sort of double construction. We need to use the new keyword once to create the array itself. But that's just an array of references to boxes. The boxes don't exist until we actually construct each of those. So somewhere, maybe when we're initializing our elements in the board or something, we're going to actually need to call new box and assign each element of our board to that new box to avoid null pointer exceptions.
Is there an inline way to declare the, or I guess construct the array and the objects at the same time?
I don't think so. I mean, I can do these two on the same line. It would almost have to be some particular thing in the language made just for that, because I don't know of any way to take the elements of Java and say, you know, automatically call the default constructor on each of these.
Yeah, I think maybe it's C#, I don't know, but you can say like equals, or maybe it might not be this, but you know, equals curly bracket, and then like, you know, new box.
Yeah, I mean, like in C, when we declare an array, we can set it equal to something by putting, you know, comma separate things in curly brackets, or we can set the whole array equal to 0 by setting it equal to just a single 0 in curly brackets. And maybe there's something like that in Java, but I'm not aware of it.
Yeah, I haven't dove too deep into it. I just
Yeah. But I always like to imagine I'm getting paid per line, so that makes it easier to write lots of lines of code. All right. Well, I think those are the main gory details, right? So this is you know, overviewed in the assignment prompt. Making the board a 2D array of boxes. This is what we just did with the mouse clicks, right? But you know, with lots more detail. And then drawing the board is your paint method. And so you know, at the end of the mouse click, you would basically call repaint, and that will queue up a call to paint, and paint will go ahead and redraw the board. Yeah, I think C# is pretty popular in here. It's pretty popular in general.
It's a really cool language.
Yeah. I'll dig into it one of these days. All right. Other questions?
I guess I haven't really got into it much yet, but I have a bit of an offset for my X and Y. It's, instead of starting at 0, it's starting at 20, just to kind of give it a little padding on the side.
Mm-hmm.
Is there going to be any difference to initializing any of this stuff, or not really? I'm just going to take X as 20 to start kind of a deal?
I think the only thing that's going to change is your coordinate arithmetic. And so, for example, to find, you know, row and column, I would want to do y minus 20 over cell height, x minus 20 over cell width.
Okay.
And then on these corners, I would want to add, you know, an offset of 20 to each one. But you can also avoid that by doing this idea of a panel inside a panel. So if we just had a single J panel, then 0, 0 would be, you know, up here, and that's no good. But if we're putting a separate panel in here, and you know, take off the border so it doesn't look goofy, and don't put a button inside the middle of it and such, then you know, 0, 0 would be right here. It's okay that that's the corner of the panel. The only difference is if you click a little to the left, this panel won't pick up the mouse event. So it could be nice to, you know, actually move it in a bit. And then if you click over here, your nearest edge code might still work.
I'd simplify this even further by only making a row column length, so everything's in a nice perfect square, and you only have to use one constant.
Mm-hmm. Right. Yeah, so you could just have you know, size instead of cell width and cell height, and then everything's gonna stay square. There's lots of flexibility here, right? So you can make these things variables inside your program and just, you know, set them to 50. But number of rows, number of columns, right? Definitely make those variables also. So instead of making 8, 8, do, you know, number of rows, number of columns. Instead of checking to see if the column is less than 7, see if it's less than, you know, the number of rows, number of columns minus 1. And these things, you know, you may not use these, but it means that in the beginning of your code, if you simply change, you know, number of rows to 16 and number of columns to 8, you could play on a 16 by 8 board, and everything should work automatically. And it also means that you could make your game board resizable, and when the board is resized, you could take the current number of pixels across, divide by 50, and say, hey, that's the number of columns. And take the height, divide by 50, that's the number of rows. And now as you grow or shrink the whole window, you can play on a different size field. And that can be kind of cool. And this is all kind of in the line of avoiding magic numbers, right? If I hardwire a bunch of 50s and a bunch of 8s, and then I want to change something, I got to go through and I got to find all of those and know which ones to change. And, you know, somewhere in there I've got, you know, a 7 because I wanted to know if I was, you know, not in the rightmost column. So I got to not just change my 8s, but change my 7s and so on. And if you keep things kind of general up front, it's a lot easier than going back and trying to change it later. But it also, I think, helps you when you're writing your code, right? Especially if you had a lot of these magic numbers kicking around, right? It's much easier to think, you know, is my column less than or equal to the number of columns? Well, that's you know, easier than seeing a 7 or an 8 or an 8 minus 1 or something. So along those lines, right, this kind of general advice of, you know, like picking good variable names. So it's Java, it's not Fortran, so you can use more than one letter per variable, and take advantage of that, right? If you have a Boolean to tell you whose turn it is, I wouldn't recommend calling it turn. Because if turn is true, what does that mean? Is it player 1 or is it player 2? I don't know. So you could make a Boolean called, you know, player 1 turn. And if that's true, it's pretty clear, oh, it must be player 1's turn. And if it's false, oh, it's probably player 2's turn. Or you could have an integer, which you switch between 1 and 2, that represents the player number. But do something that is going to, you know, make it more pleasant at 3 a.m., you know, next Wednesday morning when you're trying to finish this thing up and you're thinking about a physics test that's coming up and SLPs and so on. Do something that's going to make it, you know, a little more pleasant to look at your code, and it'll be like, oh, player 2 turn, okay. And, you know, you don't have to get fancy, but you could. Right? Instead of having a text field called player 1 and a text field called player 2, I could make an array of text fields indexed with indexes 0 or 1, and I could have, you know, player 0, player 1, and then if I want to know the current player's name, I could just say, you know, text field array bracket current player number, and that would give me their text field. And I could have the scores be an array of text fields where I write the scores and so on.
I usually like to make very long variable names.
Mm-hmm.
And I read something very interesting the other day, but hadn't yet considered. I always found it annoying in C that function names were usually like 6 letters. But
Are they?
The reason for that,
Yeah.
like printf. But back in those days, the compiler would only recognize like 6 letters of a variable or function name.
Yeah. So why is ls the command for listing the files in a directory, you know, instead of list or dir or something like that? A lot of these commands in Unix were really short because, you know, somebody had to write this code, and some of it was written in assembly language. Eventually, it was written in C. But yeah, these are sometimes legacy limitations. But certainly for the stuff we're writing ourselves, you know, you can be as kind of verbose in your naming convention as you like. I took a COBOL course once. COBOL is an interesting language because most of your statements look like complete sentences, including ending with a period. And it really kind of got me into the groove of using, you know, long variable names, like current customer's gas bill, right? Might be a good variable name instead of X, which is what I would do in Fortran, you know. And there's some sort of freedom in letting yourself, you know, name things for something that describes what they are, instead of trying to constantly remember, you know, is temp equal to the current node or the previous node, you know. Current node and previous node might be better names.
Yeah, I've been spoiled rotten by IntelliSense and just like typing the first 5 letters.
Yeah.
So I make it really long.
Mm-hmm.
Yeah, it's really nice with, again, C#, like, in IntelliSense, if you type 4 and then you just hit tab, like, twice, I think, then it will just fill most of the for loop for you.
Yeah, that can be cool.
Yeah.
Or like CTOR, the setup, automatically set up constructor for you.
Mm-hmm. Yeah, and so you know, some of that happens in Eclipse. I've got some of that turned off. I'll eventually have all of that turned off. But you know, as you're typing, it's kind of trying to anticipate what you're planning to do. So last point dot, and here's all the things that I might call. And I think I don't actually know how to do this, but I think there's a way to sort of get the template filled in, and it'll show you, you know, examples for these, and you can either accept those or you can overwrite them, and so on. And so that can all be convenient and time saving once you're used to it. Or you can just turn it off like me and be grouchy. All right. Any other questions, comments at this point on PA4 or other stuff? So let me talk about something that, in my opinion at least, is not super duper critical, but it's something that you'll see, and it can be useful to work with. So these event handlers, for example, button clear is the name of a button, right? And it's a J button, and J button has a method called an add action listener. And if you look at the documentation for that, it basically says, hey, you can specify the name of an action listener, and that's the code that will be called when the button is clicked, or whatever event you're specifying happens. And so here's an example of how we can set up a listener. So in this case, I'm let's see. I think I have this backwards. Yeah. So in this case up here, right, I'm defining a class called, so let me just scrunch this up. I'm defining a class called myListener, and I'm saying implements action listener. It's a little bit like when we extend a class, except action listener is what's called an interface. And so it says basically we're going to follow this blueprint for something called an action listener. And the main thing that does for us is it says, hey, you have to write a method called public void action performed that takes an action event argument. So it sort of requires us to write certain methods. So here I'm just creating a class called myListener, and I'm making one method in there called action performed. I pass an argument to it of type action event, and the body of that method just prints out hello to standard out. Alright, if I want this line of code to fire whenever the button gets clicked, here's what I do. I construct my J button, and then I construct a myListener. So I've created an object called ML, which is a new myListener, and then I add that object to the J button's data structure of how to handle events by basically saying add action listener. So this statement right here is saying, hey, for my J button, add an action listener. Here's the action listener I want to add. It's ML. What is ML? It's an object of type myListener. What is myListener? It's a class containing this action performed method, which does this particular statement. And so to associate this line of code with a button event, I need to do both of these things. Which means I need to create a new class, right? Say that it implements this, put my code in there, and then construct an object of that type of class and add that to the action listener. And that's a lot of overhead, right? I'm doing all of those things, but really my goal is, hey, when you click the button, I want to run this line of code. So there's this notion of an inner class. And an inner class basically lets us do all of this declaration right inside here. So we can construct a button and we can say add an action listener, and for the argument of the action listener, we will at that point define this class that implements action listener, write an action performed method, and put in our code that we want to have executed. And so the inner class version of this would be like this. So there's the J button. We say add action listener, and then everything, ooh, that's a feature. Everything inside here is the argument to the add action listener method. So up here, what argument did I pass? I passed ML, which was an instance of my listener. Down here, my argument is a thing containing the new keyword, which says, hey, I want to make a new action listener. So I'm constructing an object of this class, and inside there I'm overriding the action performed method, or specifying the action performed method, and then putting my code inside there. And so this is a convenience, basically. It's a shortcut to do both of these things in one statement, basically. And that pops up again and again in the code that Window Builder makes for us. So every time that we add a method to respond to an event, it's basically going inside this kind of boilerplate code that's already been written for us. So if we come over here and we say jframe, let's add an event handler for window. How do I do resized? Component resized, right? Same thing. So now I'm adding a component listener of type component adapter, and I'm making a method called component resized. And here I'm going to say, you know, window has been resized. And then when this runs, anytime the window changes size, I get a message. So those are called inner classes, and I'm not going to test you on those. They're kind of a nightmare to write by hand, because you know we have an opening parentheses here. This is the corresponding closed parentheses. Inside there we have a declaration of a constructor, and then curly brackets from here up to here, and then everything inside there will be the method or methods that you want to write, and that's all kind of treacherous to try to nail down by hand, but you know, IDEs will write that for us. So they're useful to know about, but mostly it's just when you're working with something like Window Builder or you know some other IDE that's creating this code for you. That's what all of this business is about. But you can live without them, right? You could just do this the manual way, like that and that.
I used one of them in PA3.
Oh, cool.
My node class.
Oh, I don't think I noticed.
Yeah, it's just so specific, but why not? Maybe do the same with the box here.
Mm-hmm.
Unless it's generalized enough. You know?
Right, right. All right. So let's wrap up by talking a little bit about color. And this is pretty general across a lot of different kinds of systems, different graphics interfaces, and so on and so forth. So we're drawing rectangles, we're filling them in, and they're coming out black, right? That's the default foreground color on this panel. And we could change that, you know, in the properties of the panel, certainly. But we can also change that in code. And so there's a class just called color. And color has a ton of statics. So there's a static field called black, or uppercase black, or blue or uppercase blue, and all of these come in both lowercase and uppercase because, you know, it saves typos. And there's a red, for example, and these are statics, which means we can say color, the name of the class, right? Uppercase C color dot red, and that represents a color. All right, we can also construct a color, and we can construct it a number of ways. The classic way is to pass it 3 integers, R, G, and B. And so these are the intensities of red, green, and blue that you want to use to mix together to make a color. And for light, these are our primary colors: red, green, and blue. For pigment, for paint, I think it's red, yellow, blue. But for light, it's green. And each of these is typically a value from 0 to 255. So if you think of an old style cathode ray tube, right, there's 3 electron beams, right, corresponding to red, green, and blue, sort of. And so this is the intensity of each one. So if I say I want red to be 255 and green and blue to be 0, I'm going to get a red dot. And if I say I want red and green to be 255 and blue to be 0, I'm going to get a yellow dot. And so you can mix these up however you want. And you can construct these with integers for red, green, and blue. You can also specify an alpha value, which is roughly an intensity. You can specify it with floats. And a few other ways as well. So, and then there's all these methods like brighter will just, you know, bump up the values of red, green, and blue in a way that makes the color brighter or darker. And you can get the components of a color and so on and so forth. But mostly, we're just going to use these in the graphics class. I'll just find it. So in the graphics class, we can say set color and we can pass a color. And so we could do something in here. Let's do this in the constructor, maybe. Super cool panel. Well, I'll just do it in my draw rectangle. So let's draw in red. Actually, I'll do it down here in the paint method. So I can say g.setColor, color.red. And that should be all I need, right? That should set the foreground color, and anything that I draw after that should come out in red. So if we run that, we'll get red rectangles. So if you want to go tutti frutti, you can look in your math class. And there's a random method. Returns a double between 0 and 1. So we could do something like this. So if we said g.setColor, new color, 255, 128, 16, right? I'm saying let's construct a color with this much red, this much green, this much blue. And so that'll be some probably pukey kind of color. Well, that's kind of a cool orange. So we could do something like this. So we could do math.random times 256 and cast that as an integer. And so this will give us a random number between 0 and 255. So when you work with randoms, usually it's greater than or equal to 0, less than 1. So if I'm getting a number less than 1 and I multiply by 256, I'll get a number less than 256. So when I truncate to an integer, I'll get a number from 0 to 255, which is a legal value. So we'll draw in a random color.
You have to use random in a new language. You have to find out if it's exclusive or inclusive.
I know, right?
Pretty annoying, huh?
Yeah. So we'll generate 3 random numbers for red, green, and blue, and then we'll set the color to be just based on those. And this should just give us, you know, a tutti frutti kind of thing. And there you go. But this is not what we expected, right? Sorry?
Have you ever heard of the Creatures game?
Yes.
I actually did this. I had to make a custom class for my Creatures game.
Oh,
As
cool.
part of the project last time, and I actually did that for my creature. Every time you took a step, it changed to a different color.
Nice.
Pretty
Cool. So we did these up here before we entered our for loop. If I simply move that down to inside my for loop, then we'll get a nice tutti frutti thing, but slightly disturbing. So that's really all there is to color, right? There's a default color for the foreground, and you can change it by calling this set color method. And if you just want a fixed color, you could use a static like color.red, color.green, and so on, or you can construct it out of intensities for red, green, and blue. And that can be useful if you're thinking embellishments for PA4. Color's always nice, so you know you can color code boxes differently based on who owns them or whatever, right? Dealer's choice. Have fun exploring and using as you like. All right, that's probably a good place to end here. So Thursday, remember your midterm is at 1 o'clock on Thursday. We'll go from 1 to 2. If you have extended time, you'll probably want to turn off Zoom at 2 o'clock because we'll start lecturing at 2:05. I recommend people be in Zoom during the exam so I can, you know, mention corrections and changes and stuff like that. But I'll keep my mic quiet unless I have to tell you something. But plan, you know, to hop onto Canvas, download the PDF at 1, upload your final answers by 2, and then we'll go ahead and lecture the second half of the class. All right, come by office hours tomorrow if you have any questions. Otherwise, have a good afternoon, and I will see you next time.
Have a great day.
Thanks, you too.
Have a good one. Thanks.
Thanks, bye.